Hello everyone. Today we will start about the asymmetric cryptography and the public key infrastructure. That is about our seventh topic, right? So, about our seventh topic. If we see earlier, we studied about the introduction, threat vulnerabilities and risk management, security framework, threat modeling, access control and identity management, cryptography, and last we studied symmetric cryptography. Today class we will study about the asymmetric cryptography, that you can see the public key in cryptography, cryptography, right? Or the asymmetric cryptography. Also, we will study about the public key infrastructure, public key infrastructure, infrastructure, infrastructure. Okay, so we will study about those kind of things today. That means what is asymmetric cryptography, how it works, what are different algorithms. Those kind of things will be covered in asymmetric cryptography. Also, we will see the difference between the symmetric and asymmetric cryptography. Later, we will understand the public key infrastructure and component of public key infrastructure, and what is those and what why are they needed. Like this, we will study in the public key infrastructure. Okay, let's start today's topic. Okay, so let's come to the second point. So objective of this today discussion is you'll understand about the concept of asymmetric cryptography as a public key cryptography, as we talked earlier. We will explain how public and private key works together, right? Previous symmetric cryptography, there is only the private key. Now there is a two keys, public key and private key. Okay. Describe major asymmetric encryption algorithm, understand the role of PKI in secure communication. Also, we will analyze the real-world security scenario using the PKI concepts. Okay, these kind of things we were going to understand. So we will learn differentiate between the symmetric and asymmetric cryptography, and we will understand how the public key, private key, and key pair uses. We will understand the PKI components and their roles, and also we will study some real-world scenarios for the asymmetric cryptography concept. So the outline of today's discussion is asymmetric cryptography, public and private key, asymmetric encryption, common asymmetric algorithm, then about the public key infrastructure, then component of public key infrastructure, then application of asymmetric cryptography and PKI, and case studies and summary and learning. So, okay. Now we will go about the problem. So we have to understand why we come to the asymmetric cryptography. First, we have to understand this point. Why we come to the asymmetric cryptography? Because we have already the symmetric cryptography, right? So then what the need to come asymmetric? What the need to come asymmetric? From symmetric to asymmetric, what the need to come? So as we discussed in the last class, what the drawback of the symmetric cryptography is the key transfer. Key transfer. Key transfer. So this is the drawback of the symmetric cryptography. What happens if the key will be transferred? That means key can be hacked. Key can be hacked or hijacked. Key can be hacked or hijacked. If key are hacked, that means any message, any encrypted message can be decrypted in between also in the transmission medium also, right? In the transmission medium. So this is unsafe. Now with the message, we do not need to transfer key for the security of the encryption, right? So that if we will not transfer the key, if we have a public and private key differently at two places, that sender share the message with the sender share the message with his public key, and he has how they will understand how the asymmetric cryptography works. But now we just try to understand if there is no transfer of key, then there is a chance of the hacking key is very less, right? So asymmetric cryptography deals with two keys. So there is a no transfer of the key. So risk of key hijacking will decrease. Risk of key hijacking is decreased. Key hijacking. Risk of risk of key hacking is reduced, right? So this is the main risk of key transfer and key hijacking or key hacking. Then to reduce the key hacking risk, there are two keys so that there is no need to worry about the key hacking, right? That's why it is needed the assignment cryptography is the main reason. Now we'll see the different other reason as well. Okay. What are the different reason? Same secret key must be shared. And the problem is symmetric cryptography. What are the problem? Same secret key must be shared. So we already discussed about it. Key distribution is difficult and risky. We already talked. Not clear for large network, right? Asymmetric cryptography solves this by using two different key, enable secure communication over open networks, support authentication and digital signature as well. Okay, so we understand why. So we have a few things for understanding why, what, how, where, like this, right? So we understand why asymmetric cryptography is needed. Okay, now let's come to the point which says what is asymmetric cryptography. Okay, so let's see. Asymmetric means symmetric means what? We have seen the encryption and then decryption. If encryption added, decryption minus. So that's why it's a symmetric. But in asymmetric, we in symmetric also we have a key transfer also. A private key going to from this place with the message to this place, right? So this key will be used to unlock the things, right? To get the original things, right? But now here in asymmetric cryptography, how it works? Suppose this is the user A. This is the user A. He has a two keys, public and private. Okay. So what will happen? Public key is always available in the domain. Okay. User B has also public and private, right? So what happened? These public keys are available in the domain. So if A want to send the message to B, if A want to send message to B, then what will be done? A will A will encrypt the message with the B's. A encrypt the message B's public key. Now, when message reach to the B, we decrypt by B's private key. Okay, that's the way. So, and also one more thing, the key of the person or key of the things which is used to encrypt, same person's key need to use the decryption. So if A's public key used for the encryption, then we cannot use B's private key for the decryption. If we want to encrypt from the B's private public key, then only we can decrypt from the B's private key. Okay, so that's why public key is no problem. You can take the public key, you can do encryption, but you cannot do the decryption from the public key. Unlocking can only be that same person's private key. Okay, so now the security features increased. Okay, now security features increase. Also, there is a no need to worry about the high key hacking. Okay, so this is a very much advantage. Although because there is a two key process, so this is a large memory consumption and time consuming large memory and time consuming. Okay, this is what large memory and time consuming. But when we have the some new connections, if we want to do not want to transfer our key, then it is better to make the encryption of cryptographic encryption by asymmetric cryptography so that the key cannot be hacked and the communication will be end-to-end encrypted. So I hope we understand what is asymmetric cryptography. That is not symmetric. That means that one key will not be used at encryption and decryption. Okay, what will happen if A want to send a message to B? Then A will send a message to B by using the B's public key so that when the message reaches to B, we can we can decrypt the message by using the B's private key, right? So there is also the condition that same person's public key and private key will be used to encrypt and decrypt the message. So if we want to send the message to A, then A's public key will be used for sending the message to A. Then A private key can be used to A private key can used to decrypt the message, right? Like that it works. I hope you understand the concept. So now public key is what shared with everyone. As I told, it's in a transmission medium. So we can ask from the third party, we can ask from the person because it's no need to worry. It's public key and private key keep the secret with the owner. So private key is not shared. Data encrypted with one key and can only be decrypted with the other, right? Same person's other key can be decrypted. Public key encrypted, private key decrypted. Okay. So as I told, the same way suppose there is a person X, there is a person Y, private key, public key, that want to send the message to here. That public key, private key he has also. His public key is in the domain all. So what he will ask the third party or the person only to get the public key. Okay, now he will send the message to this person with his public keys encryption. Now when it reaches to him, he if the message comes to his public key encryption, it can be decrypted by his private key only, so that he can read like that, he or she can read like that. Encryption and decryption works in the asymmetric cryptography. I hope you understand the concept. Okay, so we can see encryption algorithm allies Bob's public key. Okay, Bob's private key, decryption algorithm, Bob's, right? So Bob's public key sending, the public key locks, the private key locks communication direction. So if allies want to send a message to Bob's public keys through the message will be sent by the encryption, and Bob's private key will be used to decrypt the message, right? Like that it works. Okay. Asymmetric cryptography, there are two keys you can see, private and public key. Now let's go to next slide. We understood about the what is asymmetric cryptography. Now let's come to the how asymmetric encryption works. How also we covered what we understood. It has a two keys and how it works, not a symmetric one, asymmetric one, right? And it works with the public key and private key. Now how asymmetric encryption works? Website user, suppose any website user send the message. Their user digitally sign their data using the recipients of public key. Okay, recipients of public key in the case wave server. Okay, like the encrypted data travels securely between parties across the public channel, safe from the middleman in the middle attack. Then it reaches to wave server. Then wave server uses the private key to decrypt the sensitive data on the backend. Okay, this is the way how asymmetric encryption works. I already told in a simple manner in the last. Okay, in the last one. Let's see the next slide. Asymmetric cryptography. We understood already asymmetric cryptography is private key. Okay, piece private key. Suppose there is a piece private key, the function of G is K private and C. Now this C is a function of F public key and the private key, right? So what will happen? This private key and this public key, two keys are there. So if the two-person is there, there are needed two N keys, means four keys. Okay, in the case of asymmetric. Okay, in the case of symmetric and C2 keys are needed. Okay, so suppose two-person, two C2, that means one key. Okay, but here suppose two-person, two cross two, four key, something like that. Okay, I hope we understand this concept. So here we understood what plain text, encryption, cipher text. Okay, that is allies. Public key distribution channel, we knows the public key. Now when it reaches to here, because it's used the public key of the Bob. Now key generation process, private key of Bob will be used, ciphertext converted to plain text. Okay, that is how it works. Okay, now we understood about the asymmetric cryptography, how it works. And let's see the public key and private key. So clearly, public key used for encryption, distributed openly, used by senders. Okay. Now, private key used for decryptions. Okay, and private key private key must be private key must be kept confidential, owned by the receiver. This separation improves confidentiality and trust, right? Because of no sharing of the private key will improve the confidentiality and trust. So public key encryption, asymmetric encryption, sender, plain data, public key, ciphertext data, private key, decrypted plain text data, recipient. Like that it works. Okay? I hope it covered all. Okay, let's erase that and let's come to the next point. Okay. Asymmetric cryptographic process. How it works? Asymmetric cryptographic process in the simple manner. The word file. Sender obtain receiver's public key first. Okay. A B. Sender receiver. So the obtain the public key. Okay. Message encrypted using a public key. This is use the encryption. This public key used for the encryption. Okay. Encrypted message sent to the network. Okay. Now receiver decrypt the message using the private key. Now he has a private key. So decrypt by using the private key. Okay. Even if intercepted, the message remains secure. Now the public key can be intercepted, right? Although message be secure because this private key is secure with the second person. Okay. So that only second person can understand and read about the message or about the transfer, whatever is there. Okay. So this is all about the asymmetric cryptographic process. Okay, how it works. Now let's see the next slide. Major asymmetric error. Now if the process goes, there should be some algorithm behind it. So RSA, okay, Diffie-Hellman algorithm, and we can say about the elliptical curve cryptography. Okay, so if we if we say about the RSA, it's a reversed Samir Edelman. Okay, if we talk about the RSA's full form is this means reversed Samir Edelman. Edelman. Okay, so is a this algorithm is a foundational asymmetric cryptography system used to securely transmit data over unsecured network like the internet. Named after its creation, Ron Revest and Adi Sambo, right? Because Ron Revest and Ron Rabbits and what Adi Samir has created it. That's why it's a Rabbit Samir Edelman algorithm. Okay. And Leonard Edelman was first publicly described in 1977. 1977. So it works based on the two prime large number. Okay. We are not going in depth, but it's like that. Okay. If we say here about the what is RSA, so we understood about the RSA, reverse Samir Edelman. Okay. There are three creators of that rebel Samir and Edelman. From those name, it comes to the RSA. So it has, if we see, based on prime number factorization, right? It has a two major prime number, right? It's based on the mathematical difficulty of factoring the product of two large prime number. Two large prime number, okay? Two large prime number. Okay, so this is based on the factoring the two large two large prime numbers. Okay. Now widely used in SSL, security source layer, transfer layer security, digital signature. Okay. Now Diffie-Hellman method. This is a we already discussed key exchange method, which was used to establish shared secret key. Okay, we talked about the elliptic curve cryptography (ECC). So we can say ECC is works with strong security with smaller key size. Okay, ECC is strong security, small key size, efficient for mobile and IoT devices. So mobile and IoT devices is for transfer method, is for DSL, TLS, and SSL data signatures, right? Based on prime number comparison. That means two large prime number are selected and need to be selected based on that inbox. Okay, I hope you understand. Let's see the next. Now let's come to the I hope we understand about the major algorithm, how asymmetric cryptography works, what are the major algorithm, when it started, okay, what the purpose of asymmetric cryptography, these things, right? When we understand about the what is public key infrastructure. So public key infrastructure is a framework that public key infrastructure framework that manage public key and digital certificate, establish trust in online communicate, establish trust in online communication, secure key distribution, identity verification, trusted communication over internet, right? Public infrastructure framework that manage public key and digital and digital certificates, right? That's why trust in online communication. Okay? That means whatever communication is going on online makes the more trust. We can sort the key, we can public key infrastructure ensure the secure key distribution, uh, identity verification, trusted communication over the internet. These are the PKI advantage. That means public key infrastructure advantage are secure key distribution, identity verification, and state communication over the internet. These are the inserities and this is the framework. Okay. Let's see the next component. Components of PKI means public key infrastructure. If we talk about the public key infrastructure, mainly if we talk about the public key infrastructure, encryption, certificate, public key, certificate authority, right? So we talk about the public key infrastructure. Public key infrastructure mainly works is a comprehensive framework. Public key infrastructure is a comprehensive security framework. Okay, security framework comprising hardware, software, policies, and procedures designed to manage digital certificate and public key encryptions. Okay, what they're designed to manage digital certificates and public key infrastructure. Public key encryption, digital certificate designed to manage the certificate and public key encryption. Public key, public key encryption. Okay, it establishes trust in digital network by verifying identities and securing communications through asymmetric cryptography. How it works with the asymmetric cryptography. Also protecting data integrity and preventing man-in-the-middle attacks. Right. This is the major part of the component of public key infrastructure. Now, certificate authority is the one component. Second component is there is digital certificate binds public key with their with user identity, then registration authority, certificate repository. Okay, so this is how public key infrastructure is working. Okay, you can understand it. Okay, now what happened? Okay, okay, public key infrastructure component is certificate digital registration and certificate repository. Okay, let's come to the next one. component of PKI we done it. Application of asymmetric cryptography. Now, after understanding what is component, how it works, like, and we have to understand about the application of symmetric cryptography. Application is HTTPC hypertext transfer protocol, right? HTTPC, so it's a, if we say about the properly hypertext transfer protocol, okay? Now, if we understand about the secure web browsing, STT, hyper transfer, protect, hyper text transfer protocol, and secure web browsing, right? What is the application of asymmetric cryptography? That is a hypertext transfer protocol and secure web browsing, email security, of man in the middle PCP, man in the middle PCP, and so where these kind of securities are there. Then another security is secure software updates, online banking and e-commerce, blockchain cryptocurrency. So anyone can like work on those applications and understand about the application of symmetric cryptography, secure communication, reading signature, secure web browsing, file encryption, cryptocurrency, transaction, virtual private network, right? Those are the few important applications of asymmetric cryptography. Let's see now. Okay. Let's see now. Difference between the symmetric and asymmetric cryptography. After finishing the last chapter, in the last chapter, symmetric cryptography we finished, right? Symmetric cryptography we are about to understand. We already understood today in class. Now we can make a difference, right? Single key, double key, converters. Data encryption, data decryption with the same key, with the green key, data encryption, and the red key, data decryption, like that it works. Okay? I hope you understand. Yes. So now we understand about the symmetric cryptography, single key used for the encryption and decryption. Right? Now, asymmetric cryptography, private key, public key, one key is used for the encryption, different key is used for the decryption. Okay? Like that. Okay. 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 Symmetric one, asymmetric public and private. Okay. One private. Okay. Then what to do? Then we understood about the determinants of data. So this is the difference. Let's see the case studies. First case, hypertext transfer protocol secure communication. Okay. So a user, these are the few case studies related to real world or the real problem. Okay. And now first case about the hypertext transfer protocol secure communication. A user login into an online banking website, it's a explanation browser, receives the site, its digital certificates will be awarded using CA public key awarded, wiki concerns, session key secure communications begins. Okay, so we understood about the scenario of HTTP secure communication. User log into an online banking website, browser receives website digital certificate, digital certificate way. So, public key encrypts session key, secure communication begin. Okay, so what will happen here? Through the public key, secure communication can be done, and then particular person can read by the private key using the notification. Okay. Now, what it does securely, what it does, okay, so here, see, case study one way user logs into an online banking browser, receive post website digital certificate, certificate is verified, right? Okay. Certificate public key, encrypt season key, secure communication rules, right? Like these the advantage of attending the class, right? So learning point PKI ensures secure and trusted web communication. Okay. Now case study two. This study two is about the email authentication. Okay. Company wants to ensure email are not forged. Senders sign email with private key, recover, verify signature using public key. Okay, as we discussed, how can prevent spoofing, ensure so shows message integrity and integrity. Okay. So private spoofing, ensure message authenticity and integrity, right? So we can understand the second scenario, that is the email authentication. Okay, just one more third one. Software update verification. User download a software update and explanation. Yesterday, three software vendors sign update using private key. Other user system verifies using public key. Monitor state update were installed. Learning outcome. Digital signature prevent malware and hits. Improve software update verification means the user download software update. Software vendors sign update using private key vendor system. Verify using public key only are posted. Updates are installed. Learning points. So, principles of next. Scenario based question. Okay. What kind of question are there? We understood the software update verification. We understood about the email authentication. Okay. We understood the HTTP secure document. Two, three examples we understood. Now let's understand the scenario based question. Okay. Here, scenario based question means a hacker enters up encrypted data but does not have the private key. Can the data be decrypted? Why? Not decrypted in the assignment because we need both key. Why pick an SR instead of just sharing the public keys freely to make sure the digitally it can be secure, right? In online exams, today, how can original signature prevent personalization? So if signature is matching with the registered signature, then no problem. Okay. So like that, questions we can discuss and try to get. That's for practicing in class and practicing in free time like that. Okay. So these are the things we understood. Summary, what we understood today, asymmetric cryptography. We used two key for the communication. One point we understood enables encryption, authentication, and digital certification. PKI provides trust through the certificate and CAs. Now, PKI provides trust through certificate and CAs. Okay, then what happened? What happened? Essentials for secure internet services like hypertext transfer protocols, email, and banking. Okay, asymmetric cryptography is the backbone of modern cybersecurity. Okay, so we understood today asymmetric cryptography with two keys. Last class we understood with the one keys is a symmetric cryptography. Then we understood about the encryption, authentication, and digital signature, and we understood about the public infrastructure provide the trust through certificate and CS, so that it's a provide a secure internet service like HTTP, CPS, emails, and banking. Okay, these need to be secure. So cyber data need to be secure. Okay, or data transfer need to be secure. So asymmetric cryptography is the backbone of modern cyber security. Okay, what we understood here. I hope you understand these things. So I will, like, we understood about the scenario, we understood about the PKI, we understood about the asymmetric, how it works, why it's there, what the need, how is symmetric cryptography, what the difference between symmetric and asymmetric, like that we understood and covered. So one by one, I will go from down to bottom slides. So last slide, so we understood about the summary of the cryptography, asymmetric cryptography, what we learned today. I will go from down to bottom to top slides so that we can just recheck, and finally I will summarize all things so we can sum up the our today's lecture things. Okay, so scenario based things we understood. Okay, we understood about the software update verification things, email authentication things, and then HTTPS secure connection things. We understood difference between symmetric and asymmetric cryptography. We understood about the application of asymmetric cryptography. That application can be online, blockchain, cryptocurrencies, and many more. Right? Virtual private network, file encryption, digital signature, etc. Component means certificate authority, digital certificate, registration authority, and certificate repository. That's what is public key infrastructure, manage public key and digital certificates, establish trust in online communication, PKI answers, secure key distribution, and TFI verification, trusted mobile, trusted communication over the internet. Okay, that need to be verified by the PKE and public key infrastructure. What the major asymmetric algorithm RSA, reversed, Samir, and Altman. Okay, we understood about that. And DeFi element, we understood the sharing exchange, key exchange method. The elliptical cryptography is a strong security and for mobile and IoT devices. Asymmetric cryptography process, I told, as we discussed, sender send with the receiver's public key and then receivers decrypt by receiver's private key, like that it works. Okay, and it's secure and the slow, but symmetric is fast. So when the new conversation start or with unknown person, that use the asymmetric cryptography so that no key transfer is there. But as soon as the two person know to each other and moves frequent and very long time and high data transfer is going between the chatting and the other transmission, then the symmetric cryptography comes after the knowing things. Okay. Public key and private key used for encryption, distributed openly used by the senders. Private key used for decryptions must be kept confidential only by the receiver like that. Okay, we understood about those things. We talked about the how asymmetric encryption work. We talked about the what asymmetric cryptography. It's a public key and private key things, and encryption and decryption by using the two different keys. Okay, now we understood about the why asymmetric cryptography is because we don't want the difficulty of sharing keys, right? So that key hacking is the problem. Also there is same secret key must be shared. Key distribution is difficult. Not good for large network. Asymmetric cryptography solves that need a like the cybersecurity engineers needed two different keys, level secure communication, supporting authentication to their signature. That's why we need a asymmetric cryptography. Then next, that outline we covered today, and we understood these are learning outcomes. That about the difference between symmetric, asymmetric, how asymmetric was, why we need how symmetric was, then why we come to the asymmetric one, and now what are the applications of asymmetric, what the model used in the symmetric, right? Then we understood about the public infrastructure, then we understood about the why we use the public infrastructure and also the component of public infrastructure. Then we summarize the things what we studied today. Okay, that we work today, and this is the objective of the work we fulfilled. So today work we understood about the asymmetric cryptography completely. That is also called public key cryptography. Okay. Also, we understood about the public key infrastructure. Also, we understood about the details where what transmission details needed and how to make it secure with the asymmetric cryptography. Hope you understand these things and you will like the things because in the asymmetric cryptography there is a two keys are needed. Two keys are needed, that is the private and public key. Now, one person can send the message with others public key. Now, others private key will use to decrypt the message, right? In the medium, transmission medium. So, like that, it happens in the asymmetric public key infrastructure, make sure the security in the comprehensive security framework comprising hardware, software policies, and procedure designed to manage digital certificate and public key encryptions, right? So that makes the authority of registration, certificate authority, and digital certificate, public and private key pairs, and also the certificate revocation list. Like that, things has been done by the public key infrastructure. Okay, I hope we understood the today's things about the asymmetric cryptography and public key infrastructure and the advantage and application of those, and why we shifted to the asymmetric, why the researcher shifted to symmetric to asymmetric. Now, two algorithms can work together also. Like that, things has been developed in the future scenario. Okay, so we understood the all things today related to the asymmetric cryptography and PKI, mainly in the asymmetric cryptography. Thank you for listening this lecture. If you like, please like and share this lecture. Thank you very much. And this lecture I recorded as an assistant professor of SR University, which is dominant university in India and one of the leading private university, which has a seventh rank in India at a private universities. Thank you very much to listen this video, and I hope you like this video. Please share to the friends of engineering or your high school or graduates, so our master's students or any other persons those want to understand about the cyber security things. Thank you very much, and have a nice day.